Good evening. This is video number 396. This video is meant for the beginners who don't have much knowledge of statistics. In this very basic video, I am going to explain the difference between variance. This is the formula for variance when we have population, and this is the formula for sample variance. And this is the formula used for covariance between x and y, and this is the formula for coefficient of correlation. So I'm going to explain the basic difference between variance, covariance, and correlation between x and y. If we are in the field of data science, so it will be important for us that we have a strong understanding of statistics, and we must know the difference between various related concepts. This is especially true when it comes to the concepts like covariance, correlation, and variance. Whether you are a data scientist, a statistician, or simply someone who wants to better understand the relationship between different variables, it is important to know the difference between covariance, correlation, and variance. While these concepts may seem similar at first glance, they each have unique applications and serve different purposes. I will first start with the concept of covariance. What is its definition and how does it work? Covariance measures how two variables x and y change in relation to each other. In other words, covariance measures whether the variables x and y increase or decrease together. If the variable tend to increase or decrease together, the covariance between these two variables x and y is positive. If one variable increases as the other decreases, then the covariance between the two variables is negative. Here is again the formula for the covariance between x and y, and that is equal to summation xi minus x bar into yi minus y bar divided by n minus 1, where x bar and y bar are the means, are the arithmetic means of x and y. If two quantities have a positive covariance, they increase or decrease together, as I mentioned earlier. For example, salary of employees and the number of hours worked will have a positive covariance. If a person works for more hours, their salary is higher. Example of a negative covariance would be the number of hours you practice a game with respect to the chance of losing the game. The more you practice, the lesser are your chances of losing the game. So the covariance between the number of hours you practice and the chances of losing games will be negative. The covariance value can range from minus infinity to plus infinity, with a negative value indicating a negative relationship and a positive value indicating a positive relationship. The greater this number, the more reliant the relationship. Positive covariance denotes a direct relationship and is represented by a positive number, whereas a negative number on the other hand denotes negative covariance, which indicates an inverse relationship between the two variables. In this slide, I am going to explain what is correlation and how does it work. I have already spent a lot of time on explaining this in my previous videos, but once again, let me explain. Correlation is similar to covariance in that it measures how two variables change in relation to each other. However, correlation normalizes the variance of both variables, which makes it easier to interpret than covariance. As you know, correlation can range between -1 and +1. A value of 0 indicates that there is no linear relationship between the two variables. A value of 1 indicates that there is a perfect positive linear relationship, and a value of -1 indicates that there is a perfect negative linear relationship. The formula for calculating correlation as a function of covariance and standard deviation goes as follows. This is the formula that I have already explained. This is again, this numerator in this formula is covariance, and the denominator in this formula is the product of the standard deviation of x and the standard deviation of y. Here is the explanation of variance. How does it work? Variance measures how much the value of the random variable x or y varies from its mean. A high variance indicates that the data points are spread out. A low variance indicates that they are close to the mean. The formula for calculating variance for population and the sample data will be explained in the following discussion. Again, the numerator is called the variance and the denominator is called the degrees of freedom. The numerator gives us the measure of how much x varies, while the denominator tells us how many data points we have to work with. And this is the population variance formula, which is denoted by sigma square, and that is equal to summation xi minus mu square divided by n, where mu is the population mean, and its sample counterpart of the variance is denoted by small s square, and that is equal to summation xi minus x bar square, where x bar is the sample mean and its degrees of freedom or denominator is n minus 1. Now, we understood what is correlation, what is covariance, and what is variance. We can make a conclusion. As I mentioned earlier, variance tells us how much a quantity varies with respect to its mean. So it's the spread of data around the mean value. You only know the magnitude here as in how much the data is spread. Covariance, on the other hand, tells us the direction in which two quantities vary with each other. For example, if x and y are two random variables, that the covariance between x and y will tell us the direction in which these two variables will vary. Correlation shows us both. It tells us about the direction and magnitude of how two quantities vary with each other. As we can see from the examples above, covariance, correlation, and variance all differ slightly in their calculation and interpretation. However, all three measures can be useful in understanding the relationships between different variables. Which measure we can use depend on our specific goals and objectives. I'll also show you how to compute variance, covariance, and correlation. So before I explain this, let me go to SPSS, and I have data on two random variables. One is x and one is y. The number of observations for both variable are 45. So there are 45 observations for both the variables, and both of these variables are quantitative. So first I would like to calculate the descriptive statistics of these two variables. So basically I am interested in calculating or in computing standard deviation and variances of these two variables. So let me start. Initially these two variables will be here in this box. Now I want to calculate or compute the mean, standard deviation, variance, minimum, and maximum of these two variables. So these are basically known as descriptive statistics. If I click on OK, here this table gives us the total number of observations for both the variables. Minimum for x is 1 and minimum for y is 4. Maximum for x is 10 and maximum value for y variable is 51. These are the mean values, these are the standard deviation, and these are the variances. This is a variance for x variable and this is variance for y variable. Now I want to calculate the correlation coefficient and covariance between x and y. For that, I'll go to bivariate, and then this time I'll check these two. I need these means and standard deviation, and since I need to calculate covariance, so I will click on this and continue. And after this, when I click on this, I have these two tables. So here the first table gives us descriptive statistics, and this is the mean of x, this is the mean of y, and this is the standard deviation of x variable, this is the standard deviation of y variable, and I also showed you the variance of the two. So if I multiply 2.65 by 2.65, I get this variance. Similarly, if I multiply 10.78640 by this value again, I will get this variance. This is variance for y variable, and in this table, this is the Pearson correlation coefficient between y variable and x variable, and this is equal to 0.340, and its two-tailed p value is 0.02. So this value is significant at 5%, and it means that there is a significant correlation, significant positive correlation between y and x variable. If you look at this value 9.728, this is covariance between x and y variable. This is covariance between x and y variable. And if we look at this value, so we have x, y here, and we have x here. So this is the covariance between y and x variable. And here we have x, and here we have covariance. So this is covariance between x and x. So it means this is variance of x variable. Similarly, in this in this bottom part of this table, again, this is the same like here. This is the correlation coefficient between y and x, or x and y, and it is again p value like here. This is exactly the same, and this is the covariance between x and y. This is 9.728, and this is equal to the same, which is between x and y. And the covariance of x and x, that is the variance of x, was 7.037, and here the covariance of y and x is 9.728, but the variance of the y variable is 116.346. So this is how we compute variance, standard deviation, Pearson correlation coefficient, and covariance and variance of x and variance of y. So let me go back to the tables, and you can see in this table, again, this is the Pearson product moment correlation coefficient, which I just showed to you. This is its p value. This is the covariance between y and x. This is the Pearson product moment correlation between y and x. This is again this value, and this value is the same. This p value and this p value is the same. This covariance between x and y is the same as between y and x, and this is the variance of y variable, and this is the variance of x variable, and these are the descriptive statistics. So you see, the covariance of x with x means the variance of x variable. The covariance of y and y is the variance of y variable. So, ladies and gentlemen, I explained the theory, the concept, the definition, and their computation and their interpretation in this very basic video. I hope you could easily now understand the difference between variance, covariance, and correlation. If you haven't yet subscribed to this channel and video, kindly subscribe to the channel and click on the bell icon. You will get notification about my other videos that I'll upload for you. Thanks for watching this channel and video. I request you to share this channel with your friends, with your colleagues, and with your students. Thank you.